Okay, so thank you all for joining. Welcome back. Today is going to be the final conservation class for the school year. We had a good run. We almost made it to all 5 vertebrate categories. So that is every animal group that has a backbone. We did birds, mammals, reptiles. Today we will do fish, and then the lone vertebrate category that we will not get to this year is the amphibians, which is your frogs and toads and salamanders, newts. This is the only amphibian taxidermy that I have, this lone southern leopard frog. So it wouldn't be much of a presentation if this is the only thing I had. So I guess it works out a little bit better that way. But anyhow, today we're going to do fish. I have plenty of fish around me. All in all, Kentucky has 242 different species of fish. Today, I'm going to show you 7. So we'll keep it relatively simple, 7 out of 242. Starting with this one, which is our state fish, the Kentucky spotted bass. And I'll tell you a good way of how to identify it soon. But first, I usually like to start the presentations off with trying to identify characteristics about the certain animal group. Like with birds, it was feathers. With mammals, it was hair or fur and produce milk for the young. And then now with fish, they have several characteristics about them. Does anybody know a certain characteristic of a fish? Can anybody name something about a fish? And I'll see if you raise your hand and I can call on you and you can unmute. See if anybody can name a characteristic of a fish. Victor raised his hand. Go ahead, Victor.
They can breathe underwater.
There you go. Do you know what they have that allows them to breathe underwater?
Gills, I
There you
think.
go. Yep, very good. Yes, fish have gills. You can actually see them right inside this fish's mouth. They are red in color, and you can see them through the side here. So those are the gills. Very good. All right, so gills, that's probably the #1 fish characteristic that people think of. There's a few more main ones. Let's see if anybody else can get another characteristic of a fish. Looks like we have some hands up in Miss Donahue's class.
Fish can come in small and super big.
They can come in different sizes, he says.
Yeah, that is true. Fish do come in different sizes, from tiny fish to very big fish. The biggest fish in the world is called the whale shark. Not exactly sure the tiniest fish in the world. I have to look that up. But I have a bunch of different sizes behind me that I'll show you today. Anybody else got one? So far we got gills, and then they can come in varying sizes. See, is there any hands up? I see a hand in Miss Bauer's class.
Who was it? John.
That all fishes have fins.
Very good. Yes, fish have fins. Yes, they do not have arms or legs. They've basically adapted fins to be able to move in the water. Good. So we got gills, we got fins, and then there's one more main one that I'll look for, and then we'll move on. So how about Miss Rister's class? Looks like we got a hand up in there.
Go ahead, Oliver C.
Tail.
Tail. There you go. Fish have tails. They have a tail fin. I'll tell you what that tail fin is technically called, the scientific term, in a little bit when I talk about fins. And then let's see, anybody else have one more guess? A fish characteristic. Miss Cook's class, is that? See a bunch of hands there?
Who? Rick Desmond? The fins.
I mean scales.
You said tail. The fin?
No, scales.
Scales. I'm sorry.
Yes, there you go. Perfect. Right on. Yes, scales. So fish have scales. The vast majority of fish have scales. There are actually some that do not, like a catfish. Catfish have a very smooth skin, but for the most part, the vast majority of fish have scales. So very good. So we got, the big 3, fins, gills, scales. And the one that most people think of first is usually gills. Like I said, you can see them right here. People know that fish breathe underwater using their gills, but they don't exactly know how gills work. How gills work is they absorb oxygen from the water. So all animals, no matter what kind of animal you are, you need oxygen to survive. They just have different ways of getting their oxygen. There is oxygen in water. It's called dissolved oxygen. It's little oxygen molecules floating around in the water, much less than is in the air, but there's still oxygen in water. And what they do is they will draw water through the mouth and it will flow over the gills that you see back there. And then the water will flow out the side. This here is called the gill flap. They can open and close this as basically a protective covering of their gills. And as the water flows over those gills, they're red in color, the gills will absorb the oxygen molecules out of the water. And that's how they get their oxygen. So that's a basic explanation of how fish breathe. They do have a nose. They just don't use their nose for breathing. So fish are mouth breathers. They breathe through the mouth. If you look very closely, you can see the nostril. So you see the eyeball here, and then right in front, the little hole there, that's one nostril. And then here on the other side, right in front of the eye, another nostril. On fish, the nostrils are called nares. So what they do, how they detect scent, is they will draw water in through the nares, and there's little chambers in here filled with scent receptors. And those scent receptors will detect any scent particles in that water. And then once they sense it, then they will expel the water back out through the nares. They'll basically push it out or blow the water back out through their nares. So that's how they smell. Now, the next was the scales. So most fish have scales except for like catfish. They have a very smooth skin. Fish scales are much different than reptile scales. Reptile scales, like we talked about last time, are made of what's called keratin. It's the same substance that makes our fingernails. Well, fish scales are not made of keratin. Fish scales are made of bone. So they are little thin bone plates that overlap each other and they form like a suit of armor. So if the fish goes brushing up against a rock, the rock won't cut into the skin, it will just deflect off of the scales. You can even age a fish by looking at the scales very close. If you were to pluck a scale off of a fish and slide underneath the microscope and look, you could age it. I'm going to show you a picture of a microscope image of a scale so you can see what I'm talking about. It's very similar to aging a tree. They have growth rings on their scales, just like a tree has growth rings on the trunk. You can count those and tell how old the tree is. Each ring represents 1 year of growth. The dark ring is basically the winter time, the dormant season where the tree is not growing very much. And then the space in between the rings is the growing season, spring and summer, where the tree is growing a lot. Same deal on a fish. The actual ring represents the winter, where the fish is not very active. Fish do not hibernate, but they go into a state of inactivity, where they'll just kind of be hanging out. They won't really be swimming a lot. They won't eat a bunch. They just kind of do nothing and just rest. So they don't grow very much. Then in the spring and summer, they're swimming around everywhere looking for food, eating as much as they can. They grow a lot, so that would be the space in between the ring where the fish is growing. So the ring, or the scale on the left, has 2 noticeable rings there, so that's probably a 2-something-year-old fish. And then the scale on the right has 3 noticeable rings, as a 3-something-year-old fish. So on average, a fish in Kentucky, say you just caught some random fish, on average, a fish in Kentucky will usually live around 5 to 10 years, but some species that I'll show you in a little bit will live a lot longer than that. So this here is the state fish, like I was telling you, this is called the Kentucky spotted bass. If you catch one out in the wild, it will be much more vibrant colors, okay? The green will be much more of an emerald green, and then on the white belly, they will have black dots on the white scales that form rows, like stripes on the belly. You can't really tell on this one, but if you caught one out in the wild. This is just a real old piece of taxidermy and the colors have kind of faded. But the best way to tell if it's a state fish, the Kentucky spotted bass, is when you're holding them. Most people, you hold a bass by the bottom lip with your thumb, you let them hang down like so. Well, if you take your thumb and you feel their tongue, fish do have a little tongue right in there. And if you feel their tongue, if they have a little rough patch on their tongue, it's a little toothy patch, then it's a Kentucky spotted bass. So they're not like sharp teeth. They're just like the teeth on the lips. They're just little grippy teeth that's like, feels like sandpaper. That's how they grip onto their prey and prevent them from escaping. Well, they have a little tooth patch on their tongue. It's kind of weird, but you can just feel it with your thumb. You feel that rough patch, then you know it's a Kentucky spotted bass. Now the largemouth, I'll grab that next. If you felt the tongue on, like, say, a largemouth bass or a smallmouth bass, it would just be a smooth tongue with no tooth patch on it. So kind of a cool way to identify. So here is the next fishing line. This is the largemouth bass. They get a little bit bigger, and as their name suggests, they have a very large mouth. If you close the mouth, the corner of the lip right there, if the mouth is closed, the corner of the lip will go past the eye. So it would like extend past right about to here. That's how you know it's a largemouth. If the mouth is closed and the corner of the lip is just like even with the eye or not as far, then you know it's not a largemouth. So as you see in there, there's the tongue. And if you felt that, it would be just a smooth tongue, no tooth patch there. So most predator fish, they will come up from underneath to attack the prey, and their mouth will be closed. And then once the prey is right in front of them, so like a little minnow swimming around, they will open the mouth real quick, and it creates a vacuum of water. It basically draws water into their mouth, creates like a suction of water, and that minnow and everything else, just whatever's right in front of it, just goes shoop, right into the mouth and down the hatch, and there you go. So they just swallow whole. They eat very quickly. Now you notice the camouflage on the largemouth bass. The back of them is pretty dark, and then the bottom is pretty bright, white belly. This is a very common camouflage that most fish will have. It's called counter shading. So let's say if you're a predator fish and you're looking to eat him, because you know there's always a bigger fish out there, and you're swimming from above, if you look down from above, his dark back will blend in with the dark colors of the lake bottom. Now, if you're coming up from underneath, his bright white belly will blend in with the sunshine's rays filtering down through the water, the bright light from the sky and the sun. So blend in that way too. So they blend in from above and from below. It's called counter shading. Even birds have this sort of camouflage, where birds are usually have like a white belly, and then the back of the bird is more of a darker color. So it's the same deal. So that's counter shading. The largemouth bass is probably the most popular fish to catch on our continent. You know, people from all over our continent love catching largemouth bass. They're big, cool fish. They put up a lot of fight and very fun to catch. So that's the largemouth bass. And now next, I'll go up another step to the biggest bass that we have here in Kentucky. There are several other different types of bass species. These are just the ones that I have to show you. This one here is the biggest bass in the state, which is called the striped bass. They have, as you see, more of a silver back, and then these horizontal stripes that run down the side. They're perfectly straight, little dots on the scales that form perfectly straight stripes, and then the white belly. So these striped bass will get even bigger than this. This is probably about a medium-sized one, about 3 feet long or so, but striped bass can get up to 6 feet long and weigh upwards of 100 pounds. The striped bass is not naturally from Kentucky, so it is not a native fish. The striped bass was brought here by our fish biologists intentionally. So on purpose, they brought the striped bass here and released it into Kentucky's waters, especially Lake Cumberland. We have a bunch of striper in Lake Cumberland. Some people call Lake Cumberland the striper fishing capital of the world because we have a bunch of striper in this lake. The reason why the biologists brought the striper here is, for one thing, it's an apex predator. It's like a top predator in the habitat, which is good to have because they control all the other fish populations and make sure they don't get overpopulated. And then second, it draws a lot of fishermen and women, a lot of anglers to our state. People from all over the country will come to Kentucky to try to catch some striper. So that promotes tourism in our state, a lot of visitors, so that's good for our state. But anyway, very cool fish. Their natural habitat, where they normally live, is in coastal waters. So this is one of those fish that can survive in fresh water and salt water, like a salmon does, and also like a bull shark. They can live in salt and fresh. So in their natural life cycle, what they'll do is they'll live most of their life out in the coastlines in the ocean. And then when it comes time for spawning, for breeding season, they will find the mouth of the river and they will swim up the river from the ocean into the fresh water and then lay their eggs in fresh water, just like a salmon. So pretty neat. Here in Kentucky, they're landlocked, so you know they can't swim out of the lake. They can't like escape the lake. So they're staying in freshwater their whole life, which is not a problem. They can survive in freshwater their whole entire life. They just need freshwater, most importantly, to lay their eggs. So really neat fish here, the striped bass. Now, sometimes you might catch one that looks like this, but the stripes, as you see, on this one, they're perfectly straight. That shows you that this is a purebred striped bass. Sometimes you'll catch one where the stripes aren't exactly straight, like they might be broken or skewed. They're not perfectly straight. That means it is a hybrid striped bass. That would mean a striped bass bred with what's called a white bass, which is a different type of bass in Kentucky. So if a striper and a white bass breed, they will form a hybrid striped bass. In that case, the lines won't be perfectly straight. It's still called a striped bass. It's just called a hybrid striped bass. And then you notice the fins on the guy. So fish, you know, they have different types of fins and they all have different purposes, starting with this one on the back. Most people notice this one because they watch shark movies. They go, oh my gosh, it's a shark. But, you know, sharks aren't out to get you. They're just minding their own business. That's what movies do, is they scare people. But anyhow, the fin on the back, these are called dorsal fins. And their purpose is to keep the fish upright in the water. It keeps them straight up and down so they don't roll over or roll upside down in the water. Then next you have these fins on the side here. These are like their little arm fins. They're called pectoral fins, and they help the fish steer in the water. It's like little wings that help with steering. And then down here you have what are called the pelvic fins. Those also help with steering, but a good function of theirs is the fish will lower those pelvic fins down and it will create drag in the water and it will slow the fish down. So they're kind of like brakes. And then this one back here is the same purpose as the dorsal fin. It's an anti-roll, keep them stable and straight up in the water. And then last but not least, you have the tail fin, which this is called the caudal fin. And the caudal fin is used for propulsion. They flap it back and forth, it pushes water, and that's how the fish goes. So that's like their motor or their propeller. So those are the fins on a fish. All fish will have those fins usually somehow, some way. They might be positioned slightly different somewhere on the body, but they all have the same basic purpose. So that's your striped bass. So far I've showed you 3 bass. We have more bass. I got my fish poster back here. It shows some of the other ones. But that's all the bass that I have. So now we'll move to a different type of fish, which is this one right here. This is called a crappie. Now crappie are probably the best fish to eat in Kentucky. If anybody ever says, hey, I caught a whole bunch of crappie fish and I'm having a big fish fry, you definitely want to go to that fish fry because it's going to be some good stuff. Crappie, it doesn't really have a strong fish flavor to it. Like some other fish, if you go to a restaurant, like a lot of restaurants will serve catfish and it's fine, but sometimes catfish has a very strong fish flavor. It can kind of be overpowering and some people don't really like that. Well, crappie on the other hand is not an overpowering flavor. It's a really light, white, flaky fish, very good for fish fries. But anyhow, if you look at the profile of a crappie, it is more of a condensed fish. It's more kind of flat from side to side, more of a flatter fish. And when you're a flatter fish, that means you're much more agile in the water. You can turn sharper to evade predators. So crappie, they usually hang out in the deeper water and they are a schooling fish. So there would be several of them together in a fish school. So if you ever do catch a crappie fishing, keep fishing in that same spot because there's probably more there since they're a schooling fish. So just hang out in there in the water using their nose and their vision to detect prey. For the most part, a fish's sense of smell is what they'll rely on to find their prey because they'll use their eyesight as well, but a lot of the time in the water, it's hard to see. Sometimes the water's murky or muddy, can't really see anything. So their sense of smell is very highly adapted where they'll draw the water in through the nares and detect scent particles in the water. They'll use that a lot to find their prey. But the fish's eyesight is still pretty good too. Fish eyes work similar to a human. We both see in color. We both have cone cells, which is the cells you need to see in color, cone cells, both have them. A few differences though. Fish do not have eyelids, of course. I guess you don't need eyelids when you live underwater. What are they gonna do? Oh, I got water in my eyes. So they don't need eyelids because the water constantly flushes their eye clean and free of debris. So really no need for eyelids. And then the other difference is their pupil, the black part of the eye, it doesn't really expand or contract. Now on a human, a good experiment for you to do, if you're ever, say you go look at your eyes in the mirror and you turn the lights off and you're in the dark, your pupils will expand. That is to draw in more light to help focus in low light conditions in the dark. And if you keep staring at your eyes in the mirror and you flip the light switch on, all of a sudden it's light, your pupils will actually contract. They will shrink down, and that's to prevent too much light from getting in your eye and hurting your eye. So it's kind of a way of your eye protecting itself. Well, with fish underwater, it can be kind of bright sometimes underwater, but for the most part, it's not too bright. So their eyes really don't expand or contract. Their pupils will stay the same size pretty much all the time. But other than that, their eyesight works pretty much the same as a human. So I'm going to pull up a picture of a crappie school underwater so you can see what that's kind of looks like when they're hanging out underwater together. So here's a crappie school, several of them there. And as you see, they're just kind of hanging out. So fish, they can swim down into the water and stop swimming, and they will stay put in the exact same place. They won't even have to move. Won't have to move a muscle. The fins aren't even moving, but they're just sitting right there in place. Now, if I jumped in the water and swam down and stopped swimming, I'd just keep right on sinking. I'd sink to the bottom and bounce around on the rocks. Now, if other people, somebody else jump in the water, swim down, and they stop swimming, they might just float to the top. So people are weird. Some people float, some people sink. I'm a sinker. But fish, they'll swim down there, stop swimming, and stay exactly put. Just not even, no big deal. They have a special organ in their body, a special internal organ that allows them to stay put in the water. Does anybody know what this special organ in the fish's body is called, perhaps? I'll see if anybody, this is a more of a challenging question that only a few people have gotten. But the organ inside of a fish that allows them to float in place. Miss Cook's class, I see a hand raised.
Maybe
something like the lungs or the liver.
the lungs or the liver, he thinks?
Oh, that's a really good guess. It's the organ functions somewhat like a lung, a little bit, as it will inflate and deflate. But fish do not have lungs. It's called something else, but you're on the right track. So it's kind of like that. Let's see, Miss Bowers. I think I might have saw a hand there, but maybe it went down. I don't know. I couldn't tell. Is there a hand up in your class? Could you repeat
No,
that?
definitely it's not called the stay put organ.
Oh, I couldn't hear it.
She thought it was called the stay put organ.
Right. Yeah, I guess if it had a nickname, you could call it that. All right. So I'm not seeing any more hands, but we were on the right track with kind of like the lung idea. All right. So the organ, I'll show it to you on the next diagram of fish organs here. So this is a picture of all the organs in a fish, and the organ that I'm referring to is number 13 on this list. It is called the air bladder, also known as the swim bladder. It's right in their center of gravity, right in the middle of the fish, and it's basically like a controlled balloon. They can inflate it and deflate it to match the water pressure that they're in. So basically, their inside density equals their outside density, so they're basically the same weight of the water they're in, and they will just stay in place. It's like they're floating around like a little water molecule. So that's called the swim bladder or the air bladder. How they inflate it is they will take oxygen from their bloodstream, and that's how it inflates. Now, some fish do not have swim bladders. If you are a fish that does not have a swim bladder, like a shark, maybe you watch Shark Week. I used to love watching that when I was your age. I still watch it to this day. I was watching sharks on KET last Wednesday. They have Nature Show, KET, Wednesdays at 8. And they were talking about sharks last week. But anyhow, sharks are a fish that does not have a swim bladder. If you don't have a swim bladder, you must constantly swim or you will sink. So there are fish in Kentucky that do not have swim bladders. They are called darters. They're a little tiny stream fish. They only get a couple inches long. As you see, he's just resting there on the bottom of a creek, just sitting on a rock there. So they do not have swim bladders either. Darters are a very good indicator of stream health. They are a very sensitive fish. So if the stream is polluted in any way, the darters are usually the first to go. They won't be able to survive in the polluted water. So if you do have darters in your stream, then you know you've got a very healthy, good water stream. So now the next fish we'll talk about is called a gar. As you see, it does have a swim bladder as it's floating suspended in mid-water there. A gar is a prehistoric fish. This is a fish that's been around since the time of the dinosaurs. It's like a 50 million something year old type of fish. You know, they change somewhat over time. A lot of them, you know, shrink in size. You know, they've gotten smaller over time, and certain little adaptations here and there that change over time. But, you know, other examples, you know, sharks are prehistoric fish. Alligators are a prehistoric animal that has been around since the time of the dinosaurs. So anyhow, I have a gar over my shoulder right here. A gar is a fish that has a very long snout with a bunch of needle teeth in there, and they snatch up their prey. Here he's got a baby bass in his mouth. He's getting ready to eat that. You know, fish swallow whole. They don't waste time chewing. So basically, they'll just snatch it up, juggle it around in the swallowing position, and then down the hatch it goes. They eat similar to an alligator, where they'll kind of juggle it around in their jaws, and then down it goes. Now you notice the fin position on the gar. Their fin on the back, the dorsal fin, you would expect it to be right in the center of the back, where it usually is on most fish. Well, its dorsal fin is pushed all the way back near the tail. So I have this gar over my shoulder that I'll show you. So their dorsal fin is all the way back here instead of being up here. Now, if you ever see that on a fish where the fins are kind of geared toward the back, that means it's an ambush predator. They will basically sit and wait for a prey species like a little minnow fish to swim in front of them. And with all these fins in the back, when they flap their tail back and forth, it pushes a lot more water. So they can take off a lot quicker. And they will take off like a lightning bolt. They're lightning fast. I've caught one of these before. And when I went to release him back in the water, as soon as he, you know, felt the water and got his, you know, bearings back, he took off. If you blinked, you missed it because it was so quick. He just off into the deep. So they will basically ambush their prey like that pretty fast. Now, the basic rule of how fast a fish can be is for every foot of length the fish is, they will be 7 miles per hour. So if it's a 1 foot long fish, its top speed will be around 7 miles per hour. If it's a 2 foot long fish, its top speed will be around 14 miles an hour. If it's a 3 foot long fish, 21, 4, 28. If you know your times tables, you can compute that. So pretty fast, you know, that's about a 4 foot gar or so, 3-4 foot. So it'd be 21 to 28 miles an hour. And that's pretty fast. You'd say chasing a little bluegill around that's only a couple inches long, that thing's only going 1 or 2 miles an hour, if that. And you say, man, that gar would catch that bluegill every time. Well, the bluegill has something that the gar doesn't. Like the crappie, the bluegill is more flat. It's more of a condensed fish, which means they can turn quicker. So that gar will come in at 28 miles an hour, and all the bluegill does is go, whoop, miss me. It'll just turn on a dime, and the gar will miss them. So the gar is very fast, but they can't turn very sharp. It's like a school bus chasing after a motorcycle. So very similar if you've ever watched Shark Week and you heard of a place called Seal Island. So there's an island off the coast of South Africa called Seal Island. It's an island where a whole bunch of seals live. And because there's seals there, there's a lot of great white sharks out in the water because the favorite food of a great white shark is seals. So whenever that great white shark finds a seal out in the open water, they'll chase after him. But once they get close, that seal will just turn on a dime and he'll evade, he'll dodge the jaws of the shark, and the seal will stay tucked up real close to the side of the shark. So the shark keeps trying to turn, but the seal just stays real close to his side, so the shark can never get his jaws around to bite the seal. So it's pretty neat. So basically the same thing with the gar and the bluegill. So let's see here. Next, I'm going to pull up another little diagram that I made on PowerPoint. I'm getting pretty good at PowerPoint. So here's my little fish school. So let's say, you know, if you're a gar fish and you're approaching this fish school looking for a snack, there's usually one fish that you'll go for. As you see in this fish, it's a tight school. Well, all of a sudden this one fish dropped off of the school. And that could be for a few reasons. Maybe that fish is injured, maybe they're weak, maybe they're sick, who knows? They aren't able to keep up and they've singled themselves out. Well, the predator will always go for whatever's easiest, the easiest prey to save their energy. So if you are the one fish that drops out of school, you'll be easy pickings. So don't be a fool, stay in school, especially if you're a fish. But anyhow, if you stay in your fish school, you'll be tightly packed, and the chances of you getting eaten are 1 in, well, how many fish are right there? 15. So pretty decent odds that you might not get eaten. But if you single yourself out, 1 of 1, then your odds are pretty good that you'll be eaten by a predator. So if you're a fish, you always want to stay packed in your fish school. Sometimes there's so many fish in a fish school, the predator comes in and they're just paralyzed by choice. They just don't know which one to go for. There's so many. Now the next fish sensory organ that I'm going to talk about is this here on the rainbow trout. So fish have basically what's called a sixth sense, kind of. Fish do have all 5 senses. They have their great sense of smell. They have good vision. A fish's sense of taste is actually located on the outside. Their taste buds are on the outside of the body and concentrated toward the head. So fish actually taste their food before they even eat it. Like I said, they don't take time to chew and enjoy their food. They just swallow whole. So really no sense in having taste buds in the mouth. They have very few taste buds in their mouth, if any. So taste buds located on the outside of the body. They do have internal ears. If they had ears on the outside, it would create drag in the water and it would slow them down. So their ears are on the inside and they pick up vibrations. But then this next sense is kind of like a sixth sense. It's a combination of hearing and touch. It's called the lateral line. If you notice that line going down the side of this rainbow trout right in the center, I'll highlight it here, that line right there. They have one on each side. It's called the lateral line. And what it is it's basically a hollow tube that runs just under their skin down the side of the fish. So you can kind of see it on the outside. Some fish it's harder to tell, but this one's a good example. And what that lateral line does is it basically senses all of the fish's surroundings. It picks up vibration in the water. It can sense objects like those rocks behind them, so they don't go swimming and bumping into rocks. They can detect which way the water current's flowing. They can detect the temperature of the water. They can even sense a predator approaching them. So they'll sense that predator and they'll be aware of him, and then they'll scurry off to safety, hopefully. So that is the lateral line. It's a real neat sensory organ, basically detects all the fish's surroundings. It's pretty cool. I have an actual rainbow trout right over here. I'm going to grab another piece of taxidermy here. So this is the rainbow trout. Why they call them that is basically their color pattern. On the top is usually more of a bluish green color. On the side, it'll be that pink stripe. On this one, it kind of looks orange, but in the wild, if you catch one, it'll be a pink stripe. And on the bottom, you have the white belly. They also have a lot of speckles on them. That's an additional camouflage. That's called disruptive camo. Same as a leopard or a tiger where they have spots or stripes to help break up their outline. But anyhow, the trout is a cold water fish. They've got to have cold water to survive. If the water goes above 70 degrees Fahrenheit, they will likely die. So they have to have water colder than 70 degrees Fahrenheit. They love living in streams, in flowing water, creeks, streams, little rivers. And they will usually, you'll see them swimming up the river. So they'll be going against the current. The water current will be moving this way. The fish will be swimming against the water. And the way their body's designed, it's like a torpedo. It cuts right through the water. It's called streamline, also known as hydrodynamic. So like birds, like stuff that fly around in the air, they're called aerodynamic, like a bird or a plane. They cut right through the air. Well, fish are designed to cut right through the water, called hydrodynamic. So they really don't have to use a whole lot of energy to keep up with the flow of the river. They'll just be swimming against the flow, and it looks like they're just sitting right in place, just swimming perfectly, matching the speed of the river, just sitting in place. And basically what they're doing is they'll just wait for bugs to float down the creek. They see a little bug floating down, and they'll swim up there and eat the bug. So that's basically what they're doing. So the best way to catch a trout is to do what's called fly fishing. Fly fishing is a type of fishing where you have a special little bait that looks like a fake bug, like a fly. And you cast it out there and land it on top of the creek, let it float down for a few moments. The trout will see that and they'll come up and eat it. And there you go, you catch yourself a trout. The trout are another good eating fish. Only thing about them is they have these little tiny little rib bones in there that you want to be aware of. I've eaten a few on accident in my life, so they don't kill you, but just something to be aware of. They're pretty flexible and they break, and you can just chew them up if you wanted, but something to try to avoid at least. So that's your your trout. Sometimes we'll stock these in lakes, so they can survive in non-running water, but the water still has to be cold. So if they're in the lakes, they'll usually be down toward the bottom where it's colder. If you ever swam in a lake, you probably realize you swim in a lake and you dive down and swim underwater. The deeper you go, the colder it gets. That's because not as much sunshine reaches down toward the bottom of the lake. So it's usually really warm on the top layer of water and then go down and it gets colder. Sometimes it's very obvious, like it'll be super warm right here and then you swim down like 5 feet and then boom, all of a sudden it's cold. There's actually a name for that layer where it switches from warm to cold. It's almost like a line. It's called the thermocline. So trout will usually hang below the thermocline where it's cold. So there's trout for you. We have 4 different types of trout in Kentucky. This is one of them. This is the most common one, the rainbow trout. So now if you've ever touched a fish before, maybe some of you in here have caught a fish, held a fish and touched one, you usually get fish slime on your hand. Well, that's something that the fish produces itself. Fish have glands in their skin that produce this slime, kind of like we have sweat glands in our skin that produce sweat and we sweat through our skin. Well, fish have slime glands. They produce slime out of their skin and it coats the fish in slime. Technically, it's called mucus. Some people are like, ew, are fish blowing their nose in the water? They got covered in mucus. No, they're not blowing their nose in the water, but it's covered in slime or mucus. And the big reason for that is fish slime is antibacterial. That means it prevents bacteria from growing on them. It can also prevent fungus from growing on them. It prevents parasites from getting on them, so it keeps them nice and healthy and clean. So that's the main function. It's antifungal, antibacterial, all that. And then the next function is it can help them escape a predator because they're slippery. They'll slip right out of your hand, flop back in the water and escape from you. So escape from a predator that way. And then lastly, the slime actually makes them faster in the water. All that slime coating on their skin, it reduces friction in the water, it reduces drag, and they slip right through the water, go even faster. So that's fish slime for you. If you ever do go to touch a fish, like if you're gonna go grab a fish, my suggestion for you is dunk your hands in the water first. Get your hands wet before you touch the fish, because if you have wet hands, you'll get less slime on your hand. If you have dry hands and you go to touch the fish, that slime really sticks to dry hands. So get your hands wet first, then you can touch the fish, less slime on you. And it allows the fish to keep more of its slime, which is good for them. So it's good for both parties. That's fish slime. Now the last fish, last but not least, that I have here to show you today. This is a really neat fish. This is also a prehistoric fish, alive from the time of the dinosaurs. It even kind of looks like a dinosaur, this fish. This is called a sturgeon. So as you see a couple characteristics about this fish, first their tail fin, caudal fin, it looks kind of like a shark's fin. Got the same shape. So they've kind of kept that prehistoric type of shark's tail. And then next you notice coating their body, they have these big giant protective bony plates. So they're kind of like scales, but technically they're called scutes. They're extra thick bone plates on their top, sides, and bottom. This is like a armored tank of a fish. And then you notice the mouth is on the bottom of the fish. So that tells you it's a bottom feeder. If you ever see a fish where the mouth is positioned underneath the head, that tells you that they're a bottom feeder. So he'll basically be patrolling the bottom like a vacuum. He even looks like a vacuum, like an old Hoover vacuum. And he'll be patrolling the bottom, eating stuff like crustaceans, crawfish, things like that, snails, bugs, whatever they can really find on the bottom, they'll be eating that. This is not as big as they'll get, not by any means. This here is only about, a couple feet long. Well, their top size, they can get upwards of 8 feet long, and they can weigh up to 300 pounds. So it can become a gigantic fish. On the Animal Planet show, River Monsters, with that one guy who goes out and catches all those crazy looking fish, he caught a big giant sturgeon on one of those episodes before. So it's pretty neat. In Kentucky, this sturgeon here, they are endangered in Kentucky. So they're state endangered. There's not very many of them in the state. We've actually started to reintroduce some out into the wild, restock them to try to help their populations out. So how we've done that, it's pretty neat. We've been doing it for about 15 years now. We get sturgeon eggs from the state of Wisconsin. So we've partnered with the Wisconsin Fish and Wildlife Department. They have a good sturgeon population up there. That's basically where the Mississippi River starts, the headwaters of the Mississippi River. And they've got a good sturgeon population, and we get eggs from them. We bring them down to Kentucky to our fish hatcheries, which is basically like a big fish farm. And we will hatch the eggs in this farm and let the fish grow in these controlled ponds so they're safe and sound. And once they reach a size of about 7-8 inches, that's where they're able to fend for themselves. So they're about to go out in the wild and they can be fine. We'll take them out and then release them into different places in Kentucky, like rivers. Their favorite habitat is rivers. They like to lay their eggs in the shallow part of rivers. And that's basically the main reason why they become endangered is loss of habitat. So we have a lot of rivers in Kentucky, but as you may know, on a lot of our rivers, we've built dams on the river. And when you build a dam on a river, it takes a river that's been there forever and turns it into a lake. It floods the river and back into a lake, and that's not their favorite habitat, and they need those shallow river areas to lay their eggs. So since we've lost a lot of that habitat due to dam building, their numbers have gone down. But fortunately, though, with the restocking efforts, they're doing better. We've stocked a lot into the Big South Fork area, which is the river system that leads into Lake Cumberland. And one of my buddies not too long ago caught a sturgeon here in Kentucky, and he got a cool picture with it. So you can fish for them and stuff. You can catch them, take a picture, but since they are state endangered, if you ever do catch one, you must immediately put it back in the water and let it go. So you can have it for enough time to take a picture, but then after that, put it right back so it can live and it can grow. The ones in Kentucky are probably not anywhere near the top size. It takes a long time for them to get that big. This is one of those very long living fish that can live over 100 years old. So it would take them a very long time to reach that 8-foot, 300-pound size. So the ones in Kentucky, we've been stocking them for about 15 years. They're probably, a bit on the bigger size in Kentucky. They'd probably be about 3, 4, maybe 5 feet. So it takes them a lot longer to get real big. Anyhow, that is your sturgeon. Really neat, cool looking fish. And then hopefully one day we can take them off the endangered list, and hopefully their populations do better and better each year. So that is all the fish that I have to show you today. If you all have any questions, now's time for Q&A. So I'm happy to answer if you have any questions. So we'll see if any classes have questions about fish. It looks like Miss Bowers has a hand or two up there. Okay, yeah, that's a good question. He asked if all of these fish are real or fake. These are all real fish. They're all real at one time, but they're preserved by method of taxidermy. So just like all the animals I've been showing you this year, they were real at one point, but they preserve them by method of taxidermy. With fish, I think they use some sort of laminate type of deal, and they obviously take the guts out and preserve them, laminate them, and it preserves pretty well, as you see. So not exactly sure how they make fish taxidermy. That's a very skilled profession that takes a long time to learn, but pretty interesting anyway.
KG, who spends a lot of time in Wisconsin, would like to know where the Wildlife Center is in Wisconsin.
Oh, where the wildlife headquarters of Wisconsin is. I really don't know where the headquarters for the Wisconsin Department of Wildlife is. In Kentucky, our headquarters is Frankfort, our state capital. So
Okay,
Wisconsin state capital, I believe, is Madison. So maybe it's there. Maybe it's in Madison.
Okay, thank you.
All right. Any other classes have any questions? Ms. Cook, do you have any questions?
I don't think so. I think we're good.
Okay. All right, ladies and gents. Not very many questions today, but if that's all you have, that's fine. All righty. Okay, well, if that's all the questions, well, anyway, I want to tell you all thank you so much for joining, and I hope you had a good time at conservation class this year. A little bit different than a normal year. Normally I'd be in the classroom teaching you, but this kind of worked out kind of neat. Silver lining, it was kind of fun with all this stuff I have. I wouldn't be able to carry all that into school. So pretty cool. Hope you all enjoyed. You all are such a great class. I've looked forward to you every time. So you're a really good group. So thank you so much for that. I really appreciate you. But anyhow, hope you all have a good rest of your school year. And maybe I'll see you down the road sometime. All righty. All right.
Thank you
You're
so
welcome.
much. You did a great job.
I appreciate you. Thank you very much. All right, y'all take care now.